morning. Last stretch, Friday, last day of the conference. So thanks for coming. Thanks for sticking with us. So this is next 45 minutes. Our topic is Supercharge Your Lakehouse. I'm Lindsay Allen, General Manager of Azure Databricks product in Microsoft. Robert?
Hi, I'm Robert. I'm on the product side at Databricks.
So we have a couple of main agenda items, and the Lakehouse. Azure Databricks is Lakehouse for your enterprise, lots of update and details. And the best of both worlds, the integration on Azure Data Stack. So I always put the slides up. Just to remind you, Azure Databricks is 100% Databricks feature parity, but it is a Microsoft product. We launched it in 2017 and jointly developed with Databricks, the company, and the partnership is going strong. And so if you hear data intelligence platform, Azure Databricks, it is whatever you sign with your Mac agreement, all covered, 100%. And with deep integration with Azure Stack, I'm not going to talk about all the Entra integration because that by default, there's no other way to log into Azure Databricks. And everything else is just like Azure SQL.
Okay, yeah, thanks. So if you attended the session yesterday, you would have heard Ali talk about the Databricks and data intelligence platform. I think the things that we want to call out here is that, first of all of our products are available serverless now. Now, there may be some region or something that you're waiting for, but this is the direction for Databricks. That doesn't mean that the classic stuff is going away, not at all. But everything being serverless means it's going to be that much easier to use. And we will see some of that throughout the presentation today. Each of these, so at the bottom, we basically have open storage. So Delta Lake, Iceberg, Parquet. This year we acquired Tabula. We've been working very closely with those folks to get Delta Lake and Iceberg closer together. For example, Iceberg v3 is going to have a lot of the features that are in Delta Lake. So for example, deletion vectors, that means there's a lot more parity between the two formats, making it much easier to switch back and forth. On top of that, we have Unity Catalog, which we'll go into details in a moment, but that's our unified catalog. It's an operational referential catalog, and it covers everything, every type of data, every type of workload, end to end in the Lakehouse. This is the most important thing about Databricks. And I would say the most important thing about Gen AI and where we're going is having your data management securely and robust. This is, if there's one thing you take away today, or I would like, if you take away from this conference, it's like, if your data management is working well for you, all these endeavors that you want to undertake for the Gen AI and everything else are going to profit from that. Then on top of the Lakehouse, we have all of these different apps. We provide an end-to-end experience, which basically aims to increase user productivity. But we're an open platform. That means that all of the Unity Catalog, the storage, each of the engines can all be integrated with all the different solutions out there, both the Azure Stack and beyond. Our job at Databricks is to make sure that we give you the best experience with each of those apps within the Lakehouse, in the native experience, driving productivity. And you'll see here we have the data intelligence with Mosaic, the artificial intelligence with Mosaic AI. We have the warehouse with DB SQL. There are still folks out there today that say, does Databricks have a warehouse? The answer is yes, and we're going to show you just how impressive that warehouse has become. Workflows and DLT, so this is Lakeflow. And then we have the business intelligence with AI, BI, Genie. We'll touch on that a little bit later. OK, so next slide, thank you. I just talked about the eliminating the silos, so we're bringing these formats closer together. This is extremely important. We don't want folks to have to sit and worry about, oh, I stored my data in Delta Lake or in Iceberg. Can I use it here? Can I use it there? We're also making sure that, that we have brilliant support for Parquet. We have the creators from all three at Databricks, so that's really means that we can make good progress on this stuff. And then Unity Catalog. Yeah, OK, let's build out maybe one more time. So I think there are a couple of things. I'll spend a little bit of time on this because I think it's super important. You can think about catalogs in two ways. One, there's the operational part. So this is like, the metadata of all the objects that you have under management. and then the setting of like permissions and ACLs, that kind of stuff. And then you have the referential stuff, which is like discovery, lineage, and all of that, which helps you, be more productive with that data in your system. Find that data easily, be able to audit it, track it end to end. Traditional catalogs really just focus, and this is true for data warehousing in particular, really just focus on that table piece. They extend to some other objects like views and things like that, but on the whole, it's really about the tables. They don't handle the different types of files and images and things like that, or AI models and notebooks. Databricks covers all of these things. We're the only catalog, the only Lakehouse catalog that covers all of these different objects. And then we don't just have the security piece, we have the collaboration, as I was mentioning, so the discovery, secure sharing. Our sharing protocol is with Delta, and you can share that across different platforms, so you don't have to be using Databricks in order to share your data. And you can do that across clouds, so it's the only sharing protocol which allows you to do that within a Lakehouse system. Then we have, almost there. We have the quality piece, so lineage and quality monitoring, and we'll come on to some of the details, so let's jump on to the next one. Thank you. I should come and click as well and make it easier. So access control. The really important thing here is when you set access in your Lakehouse, you want that access to be respected everywhere. This is not true of all other systems. In Databricks, it's fundamental, and there's a reason that we can do this, because everything goes through Unity Catalog, and all of the security and governance is managed by Unity Catalog. This is not the responsibility of an engine sitting on top or some other system. And what that means is that any system connecting to data in Databricks Lakehouse will have that governance in place. So basically, it's very simple. If I go to a table, or if I set up row-level permissions, they will be respected in every experience. If you're doing that through a notebook, through a dashboard, if you're using that data with a model, your user, what you're permissioned to do, that's going to be respected everywhere. And we have fine-grained access control. So we have that for rows, we have that for column masking. And then we are moving into to provide ABAC as well. This is massive. This is the thing that's going to make it that much easier for large enterprises to handle complex governance situations. So if you think about this using tags and different locations, the identity of the person, you look at the session, the time, all of these kind of complex things that you want to be able to set up. So for example, this data that's tagged with this, I want to be available to these users, during this session, but not after that session. Those kind of complex situations, without having to do some kind of mess of different things and constructs, this simplifies that whole experience. This is really like the enterprise level of governance. Lakehouse Federation allows you to connect to data sources like BigQuery, for example, here, SQL Server, we have Postgres, all these different systems, you can just connect to it and federate that data into Databricks. And that federation, that object inside of Databricks is also a UC securable as well. So that data and who can see that and how you permission it, it's just like anything else within Databricks. So the cool thing is here, let's say you've got some data in SQL Server and you want to start analyzing it. You're going to do some ingest later and use CDC, for example. You could do that with Lakeflow Connect in Databricks. We have a gated public preview for that at the moment. But in that first instance, you want to go and explore that data and maybe give access to some users. That's super simple to set up with Federation. I mentioned the Delta sharing. Delta sharing is an open protocol. You can use this across clouds, across different products. We already have a marketplace with more than 2,200 listings with 200 plus providers. And we use this technology to power things like clean rooms. If you attended yesterday's session, you would have seen that clean room demo. It's this technology that sits underneath it as well. So if you look at the combination between Delta sharing and Federation, it really means that you can connect all of your systems together through Databricks. Okay. The centralized search discovery, I'm going to show a demo on this in a little bit, but the thing I want to call out here is that we make it using data intelligence in a platform. And, well, I think the demo is on the next one, no? So let me switch to the demo.
I have a lineage there.
Yeah, let me switch. I'll show the lineage in the demo as well.
Okay.
So I'm going to just switch across for the demo. which means I have to log into my machine. And this takes a second because I have a terribly long password. OK, everyone can see the screen, yeah? So look, here, for example, I'm in Unity Catalog. I have some BigQuery data here that's being federated in. I can look at that data. I can look at the sample data here. I can go to the lineage part. So like this is a federated source, yeah? So this is data that's in BigQuery. I can go to the lineage here. This was updated a little bit longer than 3 months ago, so I'm just going to put it to a year. I can look at the lineage graph because that's a bit easier for me to understand. So here's my data coming from BigQuery. Then I have all these tables on top that use that data. If I click on this top one here, I have a materialized view that's on this other table. I have a model that's being trained off of this table as well. So I can basically click through and see all the lineage of the different types of objects that I have within the system.
It's not recording.
It's not recording.
Exactly. Internet works.
The internet works today. I'm on the demo Wi-Fi, so I'm not allowed to give the password to everyone. OK, so let me show you here also why we're doing this. Second part. So here I'm going to show you like how that data intelligence really helps us with that discovery piece, and also just starting to ask questions to our data. So here I have a table. And you can see, first of all, I have a description on this table. I basically generated this with AI. We've trained a slightly smaller, a specific model, fine-tuned a model, to basically take your table and describe, like, what is this table? Look at the column names, figure out, like, what those columns are actually used for. So you can generate all of these descriptors just using AI. Of course, you can go in and edit them as well. That's super important because when folks want to start asking questions to their data, they're not going to type in the terms necessarily that you're using for those columns and things. So here I'm going to go now to Genie, which is a way just to chat with that data. And I'm going to go here to, I had one with some coffee. Let's go to this coffee one. OK, so let's first of all, let's ask a question. Like, what type of beans are there? It's going to determine the context. And so basically what's happening now, this is like when you start seeing this compound AI system at work. So the same systems that we help you to build using Databricks, we're using those same technologies to make Databricks better.
You're brave. You're actually running the query live.
Of course. We should always run queries live. Don't let people tell you otherwise. So here we have all the types of, all the different types of beans. And the nice thing here, it explains to me what it's doing. If I'm curious about this, and I'm like, hang on, I know SQL. I'm not sure if it's done the right thing here. I can just ask it to show me that generated code. What's happening here behind the scenes is we're taking the semantic knowledge that we capture in Unity Catalog. And you can see, this is why it's super important that we have everything plugged into Unity Catalog end to end. We're taking those descriptions, the metadata descriptions that we had for the columns and things like that, so I can understand what's going on. And I take all of that context, and then I go and use another LLM. In this case, we're using OpenAI. And I say, hey, this is my context. I want a SQL query. And we all know that ChatGPT is pretty good with generating SQL. But it's only good at generating SQL if you tell it exactly what SQL you want it to generate. So you need to provide that context. You need to tell it, these are the column names up front. So we give it all of that context. And then it comes back with the SQL. And that SQL is going to be executed as me. And we can.
This context is based on your data, right? This is the
on your
instruction to the Gen AI, stop these hallucinations, right? Because now it's embedded in your data platform. It's not going to make things up because it knows what to look for.
And what I get back is a SQL. And if we go and look at the query history, you'll see that I just executed this query. We can see the time here. This is not a fake demo. This was 9:12, which means I need to speed up a little bit. But if we look there, we can see this was executed as me. We can click here and just see the query, expand the text, go and look at all the stats about it, how long it took to schedule, to complete, all of that. It was 0 milliseconds in the queue. Hooray for serverless. So let's go back.
He didn't create any hidden prompt or anything. This is already embedded in your data. You already have it. You don't need to hire somebody else to actually to write a hidden prompt, a system prompt, to make sure the AI doesn't go hallucinating on something random.
So which one is?
Don't you also have a quality check? Now Genie can allow human feedback on yes or no?
Exactly. So if we take this data set here, well, let's do another one. So which one is the most popular?
Oh, make most sense, right? To the business.
I'm curious, like which one is the most popular? It's telling me Gasha with a count of 27. Okay, top 5, please. We have to be nice to the AI as well, no? I mean, one day. Here's the top 5. Well, that's interesting. Actually, yeah, Gasha was the top, but there's another one that's joint top there as well. And I've got those top 5. I'm going to look at the code again. And you know, this looks pretty good to me. You know, we're grouping by variety. We're making sure that it's not null. We're doing a count in the proper way. We're limiting it to 5. This is pretty much the SQL that I would have written, so I'm just going to give it a thumbs up. If it had got this wrong, I would have given it a thumbs down. If it interpreted something wrong, I would have added an instruction, so the next person that comes into this Genie room that I've created would benefit from that added instruction. Okay, the last thing I'm going to do here before we move on is like, is it going to give me a prompt for that? Let me see. Look, just auto-visualize this. I'm too lazy to type visualize. There we go, and we've visualized it. So we're going to move back to the slides now.
Amazing, he did this live. All right, you want to skip
well, we
the
did,
lineage?
We did the lineage, didn't
Go
we?
ahead.
So
yeah.
we did the lineage. Monitoring and observability is built in throughout the platform. One of the great things about this is all that information we store in system tables as well. So you get like in the monitoring dashboards, and our dashboard is just built on our AI BI dashboard tech. You can also go into that dashboard and just use the Genie room from there and ask questions to the dashboards as well, which is super cool. But you can look at the dashboard. It will show you kind of how things are going. But you can drill down. You can use those system tables, and you can go and write queries or use the Genie room to query those tables as well for more detailed analysis to what's going on when you find a problem, for example. So these dashboards, they're all fully customizable within the platform, and you can talk to them. Monitoring, so let's move on. OK, this was when I was supposed to do the demo. I got ahead of myself. I'm going to hand over to Lindsay to talk about SQL.
Yeah, thank you. We're going to talk about this together. I'm like so excited about the state-of-art intelligence built into Databricks SQL engine, SQL Warehouse. For those of you who checked out on my LinkedIn, I used to own SQL Server, Azure SQL. And I know how hard it is to get the statistics right. And working with our customers, define the schema and rebuild index. We're trying to auto-stats. We try to get AI to do all this, right? Now, here it is in Databricks SQL engine. And because all these statistics collected and optimize the engine itself, without customer doing anything. This is based on actual customer queries. And no change in your code, no change in anything else other than you added more data, but it's 73% faster over time because we see the logs, right?
So just on this note, remember at the beginning I said, like, you know, we have all these experiences, all these apps basically within the lakehouse, and the warehouse is one of them. Like the number one feature for a warehouse is performance. Like everyone wants their queries to run efficiently and effectively. Our job, like we really respect great competition. You know, we have a great competitor out there, representative of the weather yesterday, and you know, we constantly push each other to make this stuff faster and faster. And I think that's really good for customers because this is what you get back for that. You know, you see over time. You're just getting better performance, which means your queries are going to run quicker. You're going to get the results back. It's going to feel a lot more slick, and it's costing you less money.
Yeah, imagine the data actually growing, right? This is a hyperlinear scaling. It's like not supposed to happen, but it's actually happening. You have more data, query runs faster. Your TCO is so much better without you actually doing anything, right? Everybody have data, endless amount of data. I remember the hardest thing to get our customer is to trim their data. The database got 100 terabytes. I said, it's too big, can we shrink it? 2 years later, it's 500 terabytes, right? It's difficult to delete data. Now you get to keep everything, don't delete anything. own your data, put it wherever it is, and this is so out-of-box performance, right? It's literally, the bigger the cluster, the more benefit you'll see on your data warehouse with data.
And everyone's asking, who is that yellow data warehouse there? That's our number one competitor in performance for data warehousing.
Okay. So concurrency, that was another thing. I remember I used to own appliance, and data warehouse appliance. So we had the concurrency restrictions because it's not very easy to manage multiple threads. And because fundamentally, the Databricks architecture is enabled for concurrency and for scalability. As more data, more user hitting your warehouse, you will see significant more benefit than this very, very traditional data warehouse architecture. So over time, the better and better. The one thing we know with Azure Databricks, as soon as customers starting put significant amount of data in Azure Databricks, the usage just growing because you don't have the headache of worrying about a traditional data warehouse. Who wants to rebuild index? Takes forever, take everything down.
And one little point I'll add to this is like the fact that SQL data warehouse is so fast and it can keep that low latency and keep those queries performant as you increase the number of users concurrently means that when you connect other solutions, so for example, you connect Power BI and use direct query to connect to that data, all of the things that you have upstream. So, with Power BI, you could have your user there with the Enter ID, you connect over OAuth to the direct query, and everything that's upstream in Databricks and Unity Catalog, all those things you're benefiting from, and you can only benefit from those things if they actually work at scale.
Yep, exactly. You're going to hire more people, you have more business, you don't want to worry about it. I ran out of concurrent connections, right? And if you look at the surface area, this is such an eye chart. I don't expect anybody to read through everything. Basically, everything you need, pretty much everything, if you can find something's not there, tell us. Everything you need about a data warehouse features is all there. And so you can actually comfortably bet your data warehouse on the Databricks DB SQL. And the migration should be fairly easy because have full compatibility of the surface area of SQL.
All right, I'm going to provoke us a little bit. There is one thing missing there for the keen-eyed amongst us. We all know it. It's like we're missing the multi-statement, multi-table transactions. Like some folks are very familiar with those.
Why do we need a transaction?
Yeah, but we're working on that. We're trying to get that into Delta. That's something that we're keen to kind of make happen. But we're going to make that happen at the right layer, at the storage layer, so everything else can benefit from it as well.
Yeah, awesome. You want to talk about this one?
Yeah, I just want to say, like, if someone used Databricks like 4 years ago and they were like spinning up a cluster and they're like, it takes seconds, we've done so much work to make it fast to connect to your data. You just saw a moment ago, I was using everything on serverless there. It's less than 5 seconds to spin up a compute on Databricks in serverless.
Because it's already running. We have a pool running.
Yeah, so we have a warm pool of stuff that we populate, and we make sure that we provision that pool like based on demand. So we're taking that responsibility on. That's something that we're paying for. You're not paying for that pool, but we keep that pool there so we have resources. But then we have to go and provision those resources. There's a lot of work that happens in that. We've spent a ton of engineering getting this down, and we continue to do it as well. Like, this is such a big, like I said, in data warehousing especially, this is the number one feature. Be quick. And if you want to scale up and scale down, so that concurrency, why does that concurrency work? Well, behind the load balance on the serverless, we're adding more compute resources as we need to kind of cope with more users running concurrent queries. In order to do that auto-scaling, we need to add compute. If we can't add that compute quickly, it doesn't scale. The latency goes up. That's why this is so important. Yeah,
literally our number one customer support ticket and incident, a job running slow. Then you go find out that the job need to scale, then we need to add more nodes to the cluster because it's supposed to scale on demand. But underneath, compute CRP, compute resource provider, need to spin up a VM. Then we need to attach the NIC to it. Then the NIC need to pointing to your ABFS and the path endpoint where your file is for your job. And all the image has to run. When this is all successful, that node will get attached to the cluster to scale. Along the way, lots of things could go slower and make your job run slower. And here's the tricky one, because we have customer calling us all the time, because as soon as the CRP spin up the VM billing meter starts. So with all those churns happening, and because we have down to the minute billing for VMs, and if your VM meter or billing, even Databricks meter is not a billing, right? So you have larger VM bills.
Yeah, and this
with
is...
the serverless, you don't see any of that anymore. It's
Exactly.
absorbed within the platform. Yeah.
That's the key thing here. Serverless, that's the responsibility that Databricks and Microsoft are taking together here. Like, this should not be a customer problem. When you have machines in your account, like, it becomes a customer problem because, yeah, things, those machines there need to get built. This needs to be built. It's like you get these complexities.
You don't have separate VM bills anymore. If that VM is not successfully accessing to your storage because the NICs attached everything, joined VNet, all that things, if that didn't happen, you're not going to see anything charged because this pool is constantly being built at the same time in the back end. All right, all the excitement in all this magic and of state-of-the-art intelligent Databricks data warehouse engine powered by Mosaic AI. And SQL, just like declarative, two key things. Of course, you have language parser. I never remember which library we're using to parse out the T-SQL. But the key is you have optimizer, you have execution plan. Optimizer creates a query plan, then you need to create an execution plan. That's all there is. We spend, it doesn't matter how many vendors are there for the SQL engine, that's all we're doing. We try to figure out how to have an optimized plan that is executable. And with AI, we can be a lot more predictive, make the life of a query optimizer so much easier because there's something I know we shipped in June. I was telling Reynolds during the keynote, I said, oh my God, you got auto stats. I didn't even know you're doing it. So Databricks SQL engine can create auto stats. Remember all the statistic redistribution with Microsoft, everybody's in Redmond, then that index always super hot, right? Imagine get that index pages laid out on the disk. We used to count every sectors and how to get it, that's magnetic these days, right? How to get it not spin too many cycles so we can retrieve page faster. And with all these, because there's AutoStats, there's AI engine can send accurate on-demand statistics for the query optimizer, and optimizer could be so much more efficient.
Yeah, I think the key thing to take away from this next session is that we built the data warehouse capability on the Lakehouse in Databricks over the last 5 years. And over these last 5 years, what have you seen? I mean, this has been the period where AI has really been blooming, no? So instead of going to build like a traditional data warehouse, we were like, no, this is the time to reinvent this space. Our engine is a compound AI system. That system is like layer upon layer, which builds up. And it starts with, as Lindsay just described, those auto statistics. So we take the statistics of the data, and we keep recomputing those. So as the data changes, as the query access changes, as the number of users change, all these kind of things, we're looking at the data and figuring out what's important here. So like all the things that we're going to do downstream from this in this compound system is basically going to benefit from that fresh information.
Yeah. So now, query optimizer have so much better time to produce an optimized plan. And also, actually, you can actually roll back. I remember I was shipping the adaptive query optimization. Basically, it doesn't matter how well you do with optimizing your plan, you could still be wrong, right? When the execution time, we have to roll back. And Databricks query optimizer can generate the plan. When the execution, because it's tied so close together, can roll back to last known ones, if in case something goes wrong. In this case, I don't think it generally does, right?
So I think the cool thing here with the query optimizer is like basically we're generating thousands of plans for your query. And then we're using AI to predict which one is the right one to use. And we keep improving that system over time. And why is this so important? Like, folks forget this. SQL is declarative, and not everyone writes great SQL. And then I have people coming in and saying, hey, I need to optimize my SQL. And like, this is not the work. When a declarative system is like, tell me what you want, not how to do it. But if we want to be really good at this, there's a couple of things we need to do. We need to make sure, and we'll see this in the next few slides, that the data storage is laid out in the most optimal way, and we keep evolving that over time as your query patterns change. And we need to kind of look at like where that data is and everything. So all of this stuff is happening constantly throughout the lifetime of your data. And this system is like making those query plans, predicting which ones to use. Next time as things change, it will generate new query plans. It will predict the better ones to use. So this keeps evolving, and you don't have to go in there and start describing in your SQL, oh, let me add this join in here because I think I have an index on that. That doesn't make sense. SQL is not for that. It's declarative. You should just tell us what you want. We will focus on the how.
Yeah. And I remember I used to have PowerPoint animation to try to rebalance files. You started with MDF, NDF files, lovely, and starting populating data, we try to actually put the data pages associated with the index pages. Doesn't take long for data to be out of balance. And with the Databricks cluster, you actually have to tell it a cluster, cluster column index to actually distribute a cluster. And this liquid clustering is like magic, because rebalancing your data files behind the scenes, right? You don't have to rely on, did I pick a right cluster column? Don't have to worry about that anymore. It does it for you. The idea is because the file I/O is still file I/O, right? So if your cluster is not balanced, you could end up having a hotspot, slow things down. So this liquid clustering with Delta 3.0 is literally, it's like save your DBA's lives. I don't know if you have DBAs anymore these days for Databricks.
Well, so Liquid's been there for a little bit now, and the first thing we want to do, we're going to eliminate the whole concept of partitioning and everything because it's just like very, very painful. And in that first version of liquid clustering, you chose the columns. Actually now with liquid clustering, you just say auto. Because someone said like, hey, we built the system, and now you're asking the users to go and tell us which columns to put in that liquid cluster. Like that liquid clustering was still figuring out like how to do the ordering and optimization for those columns. But what we figured out was looking at all this data, the statistics and everything, we should be figuring out which columns to use. So liquid clustering now, if you're using it, just put, do liquid clustering, auto, and then we will figure out the right columns. And we will change that over time in order to, again, as your data grows, as the query patterns change, in order to keep things optimal. And then the question is like, when do you do that? Well, we do that when we do that on writes, and we do that in the background compute. So whenever we're spinning up compute to do stuff, there's always spare cycles, and we're using those spare cycles to go and re-optimize the data in the background. So it's not a separate background service that you're paying for.
Yep. It's really amazing to see. Now on the execution side, right? Because the query engine now is column vectorized. It's beyond the columns, so going vectorized. So all the innovation on the optimization techniques of actually executing your query on this index, on the clustering, because Databricks, actually the engine is all built in, sees everything from the layer of how the data laid out, how it's clustered, and all the stats are managed all internally inside the engine, can be utilized from the optimized DB SQL driver and to the execution engine.
So folks are asking, like, sometimes, okay, I can run SQL and then I can run like PySpark or other things. Like, how are you able to keep like the performance and everything, the same and like keep the innovation moving along so quickly? Well, we're using Spark, but we basically took the Spark engine and then vectorized it. So we wrote it in C++. It's called Photon. I'm sure you've heard the name. It's that engine that's wired up with Unity Catalog, benefits from all the information that's there and all the governance I explained to you before. But that engine is the same engine that's being used across the stack within Databricks. That means, whether you're running SQL queries or you're using Python or Scala, you're going through the same engine, the same vectorized, highly performant engine to make sure that, all this stuff is happening super fast.
Yeah, and this is really cool. It's for the customer, manage your workload over time.
Yeah, so this is, again, that's why I was like, we have to put the slide in there about how fast we spin up compute nowadays. Intelligent workload management is only possible if you can add and remove resources really, really quickly. Like if you can't do that, it's, you know, you might be intelligent about it, but you're late. And being late is like, yeah, then you could have just as well been dumb about it, no? So like we need to be really quick with getting resources up and down, and then we need to start predicting that. Like, what do we need to do in order like to match the demand? And we optimize our system not just for things like utilization. We use like business metrics to figure out, because like there are all these different users on the platform, and the thing that's important to them is getting their results back, quickly so they can proceed to the next thing. So we're using that information to figure out like how to keep optimizing this engine.
Yeah, because in the cloud, right, you can interleave. I was so tempted to put my little screenshots of SQL runs on Superdome. I remember when I first have this huge machine, and I cannot get a CPU beyond 2%, because it's always a bottleneck somewhere, right? And with cloud, it's on Azure, intelligent engine, we don't waste resources, we don't have bottleneck for your workload. The scaling, concurrency, efficiency is for your workload.
Awesome. Now we've got 9 minutes, so we're going to go to the best of both
We
worlds.
only
Yeah,
have
9 minutes. We need to go faster.
Okay, I'll let you go first.
Okay.
You have 1 minute.
Look, first of all, folks are asking like, what is the integration points between Databricks and other systems in Azure? Fabric obviously comes up. So there are a couple of things here, and we're going to look at each of them in turn. But essentially, on the Databricks side, everything is going through Unity Catalog. Like Unity Catalog, remember what I said, governance, 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 end-to-end in Databricks, that's Unity Catalog, so we build that out. So when we're doing, for example, with Power BI, we have a direct publish straight from Unity Catalog, and all those ACLs and everything respected, we're going to come onto that. If you want to take a table, and I think, sometimes I hear from folks like, oh yeah, I want to use Direct Lake. And Direct Lake, good, you can use that as well. We have the direct publish mode. You can look at which one works best for your use case. But there are other use cases as well. Maybe you're doing some low-code thing with Fabric Data Factory, and you have a table in Databricks that you want to use there. We brought a way to actually mirror that data from Unity Catalog into Fabric, and I'll show you the details on that. And by the way, how we do that, remember, Databricks is an open lakehouse. So we build that thing through open APIs so everyone can integrate with it securely. And I'll show you in a little bit how.
Yeah, so what you have working today, Azure Data Factory, Power BI, still work. What we did is make them working better as is, right? Including Data Factory and the Power BI, everything is a lot easier. And in addition, it works with Fabric.
Okay, so look, very quickly on this one. The cycle that we've seen folks go through in the past when it comes to their dashboarding is like, they go and create their gold layer in Databricks. So this is like the curated data. Then they connect from the BI tool. They publish the thing. They start building reports. And then someone needs to change something. They need to add another table, add another column, whatever. And then they go and say, OK, let's go and repeat the process.
And somebody change a column, start again, right? So what Fabric Power BI did is have the web authoring tool online and allow the engine like a Databricks Unity Catalog to publish the schema, like your data warehouse, directly to Power BI. You don't have to go through desktop to create a PBX file, then upload, and all that anymore, right? And the authorization goes through OAuth, fully integrated with Entra, and works like charm. This is OG8, right? So with this direct publishing tool, we keep the schema synced. And there's no disconnect because it's directly from Unity Catalog to Power BI. And so all the Power BI direct query reports you had before, I keep calling it OLAP. Basically, you send the DAX query to the query engine, translate to SQL or something, and that's all working with added benefit. You don't have to have the disconnect, the change, all the schema update anymore.
So before we jump, I think one really important thing here is like your gold layer schema in Unity Catalog. You're going to just basically click two clicks. You're going to see in a moment and publish to Power BI.
Yep.
And then you have that in sync.
I will show it. This is what this demo is. So go to you. I'm not as brave, it's recorded. And go to your Azure Databricks and or wherever you are, the Databricks, that's work for him anywhere. And you can go directly and pick your workspace. You need a Power BI workspace in Fabric. And you choose OAuth, so we support OAuth authentication. There's one button click, literally, and publish to Power BI. Then you can directly open Power BI in Fabric. And then you will see in there, and you see the lineage, not lineage, the entire schema, right? The relationship, all the tables, whatever you choose in your Gold layer, and it's directly published to Power BI. From here, you can just run the report just like before, right? Because that's all Power BI need is a MetaStore.
And so saying that Gold layer is now in sync with the semantic model. And because you did the work in the Gold layer and not downstream in that individual semantic model, any other thing that you connect to that Gold layer also benefits from it. You know, there's this concept of like do the work upstream because then everything downstream can benefit from it. And this is a great example of that.
Yeah, and for the OAuth Authentic, I do want to mention right now you actually have to go in, configure the OAuth connection. We're actually working on enabled API connections, do it through API, so you don't have to actually manually configure OAuth anymore.
What that means with OAuth is that your end user in Power BI has basically, we run the query as that user in Databricks. So you get your row level permissioning, you get your column level masking, I get to do auditing for that user as well. I've got lineage, you know, what the user query is connected to upstream. So when there's a problem and he says, this is not the right data, I can go and look at, this was the query that was executed in that dashboard. These are the tables it's connected to. Okay, this is where I'm going to go and dig in and investigate. So all of that stuff you get because of this, you know, that OAuth and the integration with the Microsoft Entra ID.
Yeah, thank you. So the Data Factory, so there's two versions of. Why don't you just go ahead and take it away?
So we've got Fabric Data Factory and we've got Azure Data Factory. This features in public preview in Fabric Data Factory at the moment, and it's in private preview in Azure Data Factory.
No, it's under flag. It's a public.
It's under
preview.
flag.
So if you want to use it, we'll give you the flag.
Yeah. So if you want to try this out in Azure Data Factory, so basically, until this feature, you would go into Azure Data Factory and you would want to run something on Databricks. So you might be doing some ingestion in Azure Data Factory to Delta Lake, and then you have some notebooks and things that you want to run. And then you have to kind of start making some choices. Do I use jobs compute? Do I use all-purpose compute? And then you go and take the next notebook, and then it's like, oh, I want to run SQL. Oh, but hang on, I don't have a task for that. Like, all of that is history. Basically, you can go into Databricks, you author your DAG. Everything that you can do in Databricks is available because you're just in Databricks using workflows. So you have serverless, you have cluster reuse if you're doing stuff on Classic. You have all of the objects, so you can use DLT pipelines, you can do SQL, you can do model training, all the things that you want to do in that DAG. And then you can go into Azure Data Factory where you have your other tasks that you're maybe doing upstream or downstream, and you can just basically select that DAG that you want to run and run that as part of your ADF or Fabric Data Factory DAG.
Yeah.
The one thing that's coming like early next year to improve this is the job parameters. So at the moment, the job parameters are not there. What does that mean? It means like now I can go and select the job. You just get a drop down there, you can select it, but I can't pass individual parameters, which might be something like a specific ID for a column or like a field that I want to use in my workflow. That work is being done. There's just some API updating that needs to be done. And then that feature will be there as well.
We're writing code as fast as we can.
Yeah.
So now basically, if you're investing or continue to building whatever all your ETL flow in Databricks and co-ed jobs, doesn't matter, you use whichever compute cluster, what have you, co-ed jobs, you can browse from Data Factory, either in Fabric or in Azure Data Factory. You can see all the jobs by ID, just run them. Don't have to worry about anything else anymore.
So Lindsay and I were in Stockholm, I don't know, it was like September,
I think.
And we announced the Fabric Data Factory integration with the named jobs in Databricks, so basically that job selection there. And we're now at Ignite.
It's in ADF.
And we have in preview in Azure Data Factory. And we said back then we were going to have it, and it's there now. So I think that's pretty impressive.
We should have another picture.
We need a second picture, but it's fine. So we're working on the things that really matter and meeting users where they are today so that they can, progress and take advantage of all the good stuff.
Yeah, we would remove that feature flag.
We've got 40 seconds for the last one.
Oh, but we're in lockdown mode right now, holiday, so we're not allowed. I can't see.
It's
there, I'm sorry. No time. So the mirrored Azure Databricks Unity catalog. And this is basically, we announced public preview in September in Stockholm. And we actually have item artifact in Fabric, which is actually reflecting a Unity catalog as you choose, right? So allow you to share your entire catalog or part of catalog with all your colleagues who want to use Fabric workloads.
So the important thing here is like this feature works with any external engine that wants to integrate with Databricks. Basically, you can go into Unity Catalog, you can choose a schema that you want to share. You have to set at the workspace level to like allow the external engines to connect, and then you permission at the schema level for a user. And then we vend credentials to give path-based access to that data.
There's no time.
So there's no copying of data here. We're out of time, but this is the last one.
Let me go quickly.
There you go.
So the catalog is synced. You can choose, the clock is so low. You can choose to be static linked or dynamically synced the catalog. So the dynamic one is if you update or delete anything in your catalog will be reflected in Fabric directly, and we'll keep that in sync. We can set a schedule to every 15 minutes. If you want to be on demand, you can do on demand because it does actually have connection to Unity in order for that to happen, right? And support the tables. And some of the object is not Delta tables, Delta files, currently not supported.
Yeah.
I won't go into too much. It's in product documents.
And how you manage that data within Fabric downstream, that's on the Fabric side, but access to that data from the Databricks side, if you say like, I don't want that access to be there anymore, I want to remove that or I want to change it, you do all of that through Unity Catalog. And that credential vending is basically means that every time that Fabric or any other system connects to Databricks for that data, they basically go through this credential vending API on the Unity Catalog side, and we give them a token so they can go and access that data, and then we refresh that every 15 minutes or an hour or so that if you revoke access on the Databricks side, then it's removed on the external side. So that way we are securing your data.
Yeah, with this, you can see actually the default model metadata which shows in Fabric, and you can access it. Of course, Power BI, Lake Direct mode will work, and the reactive, what did we call it? Reactive, some of the real-time, async real-time workload data warehouse. By default, we do create a SQL endpoint on it. So this is as native as possible, have Azure Databricks inside Fabric.
Okay, we're at time and then some. Thank you, everyone.
Let's give the demo. Thanks for sticking with us.